Hello, let us solve shortest path in an undirected graph today. You are given an undirected graph having unit weight of the edges. We need to find the shortest path from the source given. Here we have the number of edges, the number of nodes n, and the number of edges m, and the edges given. And there is a source provided here. We need to find the distances from the source to the nodes. How do we are going to do it? Before that, this is an adjacent list. I'm going to take a default dictionary because this is an undirected graph. There are connections between the two nodes. So the 0 and 1 have bidirectional connection. Let us take the edges for u comma b in edges and map each of them bidirectionally. So what we have here is an adjacent list containing the neighbor of each and every edge given. So we need to find the distance right now. I'm going to implement a BFS. Let us take an empty queue, initially having the source and a list answers up to the length of the nodes, a visited set having SRC in it, and take the distance 0 initially. Let us start the BFS while queue. Initially, the queue is started from the SRC and take an neighboring queue where we can add the neighbors. Initially, we have 0 in the queue. What I'm going to do is I'm going to add the neighbors of it 1 and 3 to the queue. Those are the neighbors. So I took a temporary queue. Now I iterate through the edges in the queue and update the answer with the distance. Initially the distance of the node is 0, so we're going to add 0 to the answer. Next up, we're going to check the neighbors in the adjacent list of the given edge for in edge adj of e. Next up, we're going to check if the neighbors are not in the visited. We're going to add them to the temporary queue and mark them as visited. After all this, let us add the neighboring elements to the queue and update the distance and return the answer. Let us check it out if it works. Yeah, it is compiled successfully. Let us submit this. And it works. That's how you do it. Remember, for an undirected graph, you need to take the bidirectional adjacent list. For directed, you can take the unidirectional adjacent list. And after that, all you can do is implement DFS, BFS, or any topological sort, all those things. Thank you.